that is your mock test, Mariam, right? Models.
Yes, sir.
Yes.
तो एग्जाम कब से होगा आपका?
Sir, 17th March.
17.
हाँ? What?
Yeah. So why are you so shocked?
17th March इतना late? No, I'm shocked that yours is Alalia या फिर international, like Indian school?
It's
Indian international.
actually, sir, it's Gulf Board, I think so.
Gulf? नहीं, लेकिन बाकियों का तो नहीं हो रहा ना ऐसे.
Maybe all
Abhinav?
schools have chosen different dates again, like the previous time.
हाँ, maybe. Abhinav, you are in Indian International School, right? और
Yes, sir.
Alalia. Alalia में तो नहीं है आप?
नहीं sir.
रियाद ना?
Yes, sir.
Maybe she is also having from 17th March.
आपका कब से है अभिनव फिर एग्जाम?
सर डेट नहीं दी, बस खाली मॉक की डेट्स दी अभी तक.
अच्छा, ये मॉक का है आपका 23 फरवरी जो बोल रहे हैं आप?
जी सर.
सही है. आपका भी 17 को होगा फिर. आपका भी 17 के होगा फिर, हमको लगता है. सही है.
Sir, me?
ये हम बताएंगे आपको रीबा कि आपका कब होगा एग्जाम.
No, sir.
तो फिर वो तो अभिनव को इस वजह से बोला हमने क्योंकि अभिनव इज इन international school and also Mariam and Aisha, they are also in Indian international school, but not the same branch. I think different cities.
So the branch is same.
Branch is same.
Yeah.
Why?
It's just like IIS is everywhere in Jubail, Riyadh, Dammam,
तो
everywhere.
ये तो ब्रांच तो अलग हो गया ना.
हाँ, बस branch अलग है. I'm sorry. Oh, he's in
that's what
Riyadh. Yeah.
that's what I was saying. Branch is different.
Okay.
Okay, fine. सही है तब तो. Okay. इतना late. That means I will be starting on. अरे यार. I'm
I
worried
guess you should
about
start from April.
That's what I'm thinking now.
Yes, sir.
Right.
Our academics will start from April, 10th April.
You can start from 1st April.
I can. When are your exams ending, by the way? Like they are starting from 17th.
Mariam say.
Sir, it will end on 30th March.
30th March. Okay. नहीं, फिर I will give you a day or two. Okay, obviously. Like chemistry की क्लास तो नहीं होगी, कोई दूसरी क्लास हो सकती है बायोफिजिक्स वाले. हम तो लेकिन बोलेंगे कि पहला क्लास मेरा नहीं देने की. ठीक है ना? You get some time, है ना? थोड़ा इधर उधर होके फिर जब थोड़ा तो फिर पढ़ने का मन करने ही लगता है ना? If you get a long weekend, then after a few days you're like, okay, fine, चलो अब शुरू करते हैं. Otherwise बाद में बहुत ज्यादा हो जाएगा. अस्सलाम वालेकुम मोहम्मद उमर, how are you?
Walaikum assalam, sir. I'm fine.
You're speaking today. What happened? Like sometimes you speak, sometimes your mic is, I don't know.
Sometimes I'm using my old device. That's why.
Why you are using your old device? You have got such a new device.
Sir, sometimes it is busy. I mean, my brother is using it.
Okay.
The new one.
Acha. And today you are on time also.
Because it's the commencement of hydrocarbons. I don't want to miss it.
It's the commencement of hydrocarbons. So you have you're done with the previous chapter. You were studying previous chapter, right? Organic, yeah. Nomenclature.
Still hyperconjugation and resonance I have to do.
Acha, you have to do, but doubts are cleared, right?
Yes, I'm watching up the recorded lectures.
So I will just like give you references. Like you go there, you will get the answer. I'm not going to tell you any answers. You know how it. Okay. So in hydrocarbons, we'll be learning. We can separate these chapters as alkane, alkene, alkyne.
Sir, we don't have to write these notes, right?
No, don't have to write these notes. I will send it to you. Then there will be aromatic. Aromatic means benzene and benzene derivatives. Aromatic compounds. So for alkene, alkene, and alkyne, we will be having some similar topics. First of all, we will be looking at the structure of these things. And in structure, we'll be also learning about major part is isomer. You can get questions on isomer. Then we will be looking at like inside isomers, we'll be looking at the differences in isomer. How are these isomers different? That is physical properties. And so for alkenes, alkene and alkane, the physical properties will be almost done in isomers only. And after that, we will be looking at preparation of alkene, alkene, and alkyne, and then its chemical properties. Okay. So these are the three topics that will be 3 or 4 topics, you can say, isomers and physical properties if you add those things. So these are the topics that will be common in alkene, alkene, and alkyne. Now in aromatics, there will be some different topics. So first of all, we will be defining what is an aromatic compound, how to check the aromaticity. We're learning about aromaticity. Then we'll be learning about the preparation of benzene. And then the chemical properties and the reactions of benzene.
How the questions can be asked from preparation of benzene?
How the question can be asked. तुमको अभी हम बता दें क्या aromatics पढ़ा दे पहले या फिर we should go line by line alkene, alkene, and alkyne, and then aromatic. They can directly ask you, like they will give you some certain conditions and they will ask you the product.
Okay.
Okay, or they can tell that give two reactions for the preparation of benzene. Okay, so many questions can come, but I will be focusing on those that revolve around NCERT only, and those which are asked usually in schools. Okay, so first of all, write the topic, that is alkene. Write the topic, that is alkene. What is alkene? Alkenes are saturated hydrocarbons. Yeah, only single bonds. Hydrocarbon. Consisting CC, only single bonds. Okay. Next point is important. They can directly ask you this. These are also known as paraffins. So paraffins is made up with 2 words: param, which means little. I don't know what language. And then affinity. Affins is from affinity. It is affinis or something. Affins is from affinity. Okay, so they have little affinity. That means they are less reactive. These are less reactive. They are less reactive. I can also divide alkene into 2 types. I can say alkene are of. They can be open chain, such as, and they will have a general formula. Of CN H2N+2. Okay, some examples will be CH4, CH3, CH2, 5 times in CH3, right? So these are simple examples for open chain. You can also have closed chain. They will have a general formula of CN H2N.
Scroll up. Paraffins.
Why?
Paraffins.
Achha, you want to see, because you don't have to write, by the way. Okay, I will send you the PDF. So for closed chain,
Okay.
the smallest one will be cyclopropane, cyclobutane, cyclopentane, cyclohexane, heptane, and so on. You have to remember about these 2 things. That is the common, that is the general molecular formula for open chain and closed chain. Next is the structure of alkene. Now, if I look at any carbon atom inside alkene, then I will be looking at this carbon atom. Let's say this will be bonded with 2 other carbon atoms, and there will be 2 hydrogen atoms here. So it has 1, 2, 3, 4 sigma bonds. So any carbon in alkene, it will have a steric number. Even if I look at this carbon atom that is in the terminal, it will have 4 bonds. So steric number will be equal to 4. If the steric number is equal to 4, then the hybridization will be sp3. The geometry will be for all of the carbon atoms that is inside in the alkene. In alkene, geometry will be tetrahedral, and the shape will also be tetrahedral. What will be the bond angle? The bond angle for tetrahedral is equal to 109.5 degrees. 109.5 degrees. So the carbon, tetrahedral carbon, will have these two things, these two bonds, and this carbon atom, they will be in plane. There will be one bond that will be coming out of the plane. That will be coming out of the plane, and this is how we show it. And there will be one which will be going away. Okay, so this is how we show a tetrahedral structure. So this is solid wedge. What does it represents? Bond out of the plane. Out of the plane. And this is dashed wedge. What does it represents? It represents bond in the plane. Behind the plane. It's a better word. Thank you. Behind the plane. Okay, behind the plane. General structure of alkene. General structure of alkene. Now, moving on. First of all, we will do some isomers. And then we'll be reconsidering some of the Iupac nomenclature, and the Iupac nomenclature that you were asking about, Muhammad Umar, I will discuss it here because they can directly ask you a question from those alkenes, because all of those were alkenes, right, Muhammad Umar?
Yes, sir.
Okay, fine. So first of all, let us learn about isomerism, and in isomerism also we'll be looking back at some of the nomenclature. Isomerism in alkene. So isomerism in general, it is same molecular formula,
Different structure.
9. Same molecular formula, different property. Okay, different property. That is the baseline. So there's a triangle in science. There is triangle in science. You have structure. Okay, this structure, it gives some property. Due to a particular structure, there will be some property, and due to that property, we will have some application. Okay, so how science work is nowadays, like material science, we have done many things which goes this way. Okay, so we start with structure, property, we see the property, and then we look at applications. Then a structure, property, and application. Now what we do, if I want a particular application, we go back to what property, because we have done this like this walk many times. So we know for what application we need what property, and then we prepare a structure that will give me that property. Okay, that is going to give me that property. So the core idea of material science is nowadays like this. We have an application that we want to drive. So we look at what is the property that we are looking for. And for example, what is the application? Let us say the sole of your shoe and the base. You don't know what is that term actually. So this is the sole, and then you have some base here. So you want to stick to these two things. The property is adhesive property. Then you will go back to structure and you will look what is the property, what is the structure that is going to give me this property. So same molecular formula, but different property, Now, in this case, in isomerism in alkane, so alkanes show alkanes show chain isomerism. Chain isomerism. Now, in this, what happened? Isomers have different chain lengths. Different chain length. Let's start with CH4. Now, CH4 does not have any chain, right? When I am talking about chain, parent chain, which has only one carbon atom, I cannot arrange one carbon atom in any other form other than CH4. So for CH4, I cannot make any chain going from CH3 to CH3, right? This is the next member of the alkene, next member of the alkene group, that is ethane. So here also I have only two. So I can't, we have a chain like this, right? So I can't place anything. I can't place or I can't arrange them in any other way. I can't place or arrange them in any other way. That is why these two will not have, these two are not going to have any chain isomers. What if I look at this? What do you guys think? Can I arrange this in any other way? Can I arrange this in any other way?
Yes, sir.
Okay, so I have, so point of attachments take hai na? We are looking at which is attached at what? We have 1, 2, and 3. So these are the 3 carbons I am representing by dots, right? So these are arranged like this, hai na? These are arranged like this. So 3 is attached to 2, 2 is attached to 1. So if I'm talking about different arrangement, that means I can pick something out. I can maybe snatch out 3, and where should I put? So 3 was placed and 3 was attached to 2. Now we have only one option. I can attach the 3. I can attach the 3. So let me point. This was 3 initially, and now what I have done, I have attached it here. I have attached 3 to 1. So this is 1, 2, 3. Now this is 3, 1, 2. Are they different or are they same? Are they different or are they same?
Different.
Different.
Different. Okay. So how? So this 1 is what? CH3. This 2 is what?
CH2 and CH3.
So I think you are looking at like this CH3 and this here CH3 and this here CH2. ऐसे देख रहे हैं आप?
Yes, sir.
Yeah.
Yes,
No.
sir. Yes, sir.
No. You are not going to. You are not going to. Wait a second. You are not going to break the valency of carbon, है ना? You can't break the valency of carbon. If you look at this carbon atom, that means you have 5 bonds. So that can be true. Okay. So whenever we are talking about the chain length, you will only look at the carbon atom, and after that you will be arranging the hydrogens. Okay. So when I talk about these two things, so what I'm saying that I'm saying in these cases, we will be just looking at carbon, not groups as such, only carbons. So I will arrange the carbon like this. This is the carbon arrangement. And here we have the carbon arrangement like this. Is it different?
No, sir.
No, because we are talking about chain length, and in chain length, there is no hydrogen, there is carbon only. This? Or if you understand this, yes or no, tell me.
Yes, sir.
Yes, sir.
Yes, okay, fine. So for 3 also, you can see that there is no, wait a second. Is my voice lagging or something? Is it
No,
fine?
sir.
Very slightly.
Slightly lagging, yes.
Just slightly lagging, but it's fine generally. Okay. Now, for 3 carbons, there is no such isomer. Going next to the 4 carbon. 4th carbon is butane. Molecular formula C4H10. It is CH3, CH2, CH2, 3.
Sir, the screen is stuck for me. I don't know if for everyone else.
I can see what you're writing.
You can't see what I'm writing. Okay. Can you see now?
Yes, sir.
Yes, sir.
Okay. So 1, 2, 3, 4. Fourth carbon atom is attached on 3. What I can do? See, one thing I know for sure, if I move 4 carbon atom from me and if I am attaching it on 1, it is not going to make any changes. Yes or no?
Yes.
Yes, sir.
Yes or no? Can you see that? Right. So what I will do, I will attach the 4th carbon atom on the 2nd carbon atom. You then see what is going to happen. Is it different or is it same?
Sir, your voice is lagging and your screen is also getting stuck a lot.
For all of you,
Yes, sir.
Yes, sir.
actually, I can see that my network is bad. And okay, so we have, okay, fine. So let me just leave the class. I will join in 5 minutes. Okay, just be here in 5. Okay, wait a second. हाँ, एक सेकंड रुक जाइए. आप लोग जब तक एक काम कीजिए. Can you see the screen?
Yes.
Yes, sir.
Nomenclature. Okay. And take a screenshot. Then I will leave.
Done, sir.
Okay. So I'm coming in 5 minutes. Can you guys see my screen?
Yes,
Yes,
sir.
sir.
Okay, so we will discuss this part later. इसको हम नीचे कर देते हैं कहीं पे. I think it's not enough. Okay. So for butane, now you tell me this first structure and the second structure, they are different. Yes or no?
Yes.
Yes, sir.
Yes. Okay. So this is what simple butane. CH. No. First of all, what we'll do, we'll just write the carbon atoms. Hai na? Carbon, 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 and then carbon here. This will be CH3. This will be CH3. This will be CH3, and this will be one hydrogen here. Right? One hydrogen here. So now can you tell me both of these are what? This is also C4H10. 4 carbons, 3 plus 3, 6, 8 to 10. C4H10, this is also C4H10. This is what? Butane. And what is this? 1, 2, 3. This is 2-methyl. Propane, right? This is 2-methyl propane. So butane has how many? Butane has 2 isomers, 2 chain isomers. Following, we next have pentane. Next is what? Next is pentane. Pentane. C5H12. You have CH3, CH2, 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 CH3. Three and 4 and 5. So this is going to be my carbon initially, but which I'm doing experiments 1, 2, 3, 4. So obviously I can place it on either the second carbon or the first carbon. So if I can place in the first carbon, so of no use, it is just as adding on the fourth carbon. And also I can say that if I add on second carbon or the third carbon, it is the same thing, because you can look at it like this: 1, 2, 3. So there are many ways in order to make isomers. So one of the things that you start with simple long chain, then the most terminal carbon, you take that as the experimental carbon, and you snatch that experimental carbon, and then you start putting it on other carbon atoms. The next thing that you can do is you can shorten the length. You had 5, that the straight chain was 5. There was no branching. So what you do, you shorten the chain, and you now have what? You now have 4 carbon straight chain. And what you do, you add 1 carbon, and not on terminal, but on some other carbon. You add 1 carbon here, or here you have now 5 carbons. So here also 5 carbons, here also 5 carbons, and these are different. These are different. So this will be CH3, CH2, CH, CH3, and here also CH3, right? Now both of these are what? You can
So
count the number.
we can also put on the second one, right?
हाँ, ये second ही है, मतलब if I am talking about this is the same thing, na? Yes or no? Like it will not make any difference. I'm saying that
Oh,
third
okay.
and second carbons, hai na, they are same thing, because let me see if I put on. So I'm not doing anything. I'm just, if I'm putting on the second carbon atom, na. So देखिए, I have done nothing. I have just rotated. So see, so there is no difference. Like it's just the difference in the perspective how you are looking at. So if I've rotated something and I've formed a particular molecule, that means those molecules are same molecules, है ना? Because अगर rotate करने से किसी का structure बदल जा रहा है, यानी कि structure नहीं बदल रहा है, देखने का तरीका बदल रहा है. Structure is not changing. What is changing? The perspective of looking at things, that is changing. Yes or no, Umar?
Yes, sir.
Right. So these two are same structure. But now we can do something else. We can shorten the length of the chain even more, and I can do 1, 2, 3 carbon atoms. I'll put 1 carbon atom here, and I will put the other carbon atom here. So this is also now 5 carbons. 4 are the terminal, and 1 is at the center, and this will be CH3, carbon, CH3, CH3, and CH3. Okay, CH3. So this will be 2-methyl butane, and this will be 2, 2, dimethyl propane. 2,2 dimethyl propane. Okay, so this is about pentane. Now, let us look at hexane, the last one, then we'll move to nomenclature. Hexane. So that is CH3, CH2, 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 and CH3. So 1, 2, 3, 4, 5, 6. So I can shorten the length 4 and 5. Now I can put the carbon atom here. I can also put the carbon atom, keeping the long chain same. I can put on this carbon atom. Now these two are different. These two are very different. But if I keep this on this carbon atom, then it is going to be same as the previous one. So we have only one structure in which the straight chain is 6 carbon. Then we have two structure in which the straight chain is 5 carbon. Then I am shortening it again. Now I have 4 carbon atoms. Now there is only one structure that I can make. First structure is this one, right? So we have 2 branch on 2 different carbon atoms. Or what I can do, I can also have, yeah, I can only do this. I cannot do anything else, because if I try to make, I think I can make this. I think I can make this. Yeah, right. I can make this, right? This is possible. This is not, we have not drawn this. We have not drawn this. No. We have not drawn this. This is one of these structures. So we have one structure with 6 carbon in this chain. Then the second structure and the third structure, they have 5 carbon. Then we have the fourth structure and the fifth structure, they have 4 carbon atoms. So what you will do, you will be drawing, this is your homework, okay? You will be drawing the carbon structure, and also you'll be writing the name for all of these, okay?
Yes, sir.
Complete. Complete this. Now moving towards the nomenclature. Before nomenclature, let me just give you information about alkane. And when I'm mentioning alkene, I mean the number of carbon atom. Okay, hash sign, it represents number. And then I'm also going to tell you how many isomers are there. If you have 1 carbon alkane, then there is isomer 0. If there are 2 carbons in alkene, then you have 0 isomers. If you have 3 carbons in alkene, there is 0 isomers. We have looked at this. If you have 4 carbon atoms, then you will have 2 isomers. If you have 5 carbon atoms, then you are going to have 3 isomers. For 6, we saw there were 5. For 7, there will be 9. For 8, there will be 18. For 8, there will be 18. 9, there will be 35. And for 10 carbon atoms, there will be 75. There will be 75 isomers. Okay, so just keep this in your notebook. No need to memorize these things. Okay, no need to memorize these things. If somebody is asking you these questions, that means I don't know what to say about that teacher. ओके क्वेश्चन पूछना है, लॉजिकल क्वेश्चंस पूछिए, है ना? ये फैक्चुअल सवाल पूछिए क्या होगा कि कितने आइसोमर्स होते हैं। अभी 10 का पूछ जाए तो बच्चा 10 बनाने बैठेगा, 75 कहाँ बना पाएगा कोई, है ना? उतना तो इमेजिनेशन नहीं है किसी का। लाइक दे कैन मेक द होल 75 फ्रॉम स्क्रैच without even seeing anything. Okay, fine. So did you try the nomenclature for these two? Yes or no? Tell me.
Yes, sir.
Okay, so this is what? Achha, one thing is 2-methyl butane. Okay. Okay, so in this, first of all, tell me what is the parent chain? How many carbons of parent chain?
Second.
Yeah, second one.
6, sir.
6. Okay, so we have many terminals. And the first thing is that if you are going to choose a chain, it should be terminal to terminal. Now, listen very carefully. I am saying that whenever you have to choose a chain in alkene, okay, if it is having some functional group, then you will be choosing that chain that is having a functional group and all. That is different thing. But if you are having just alkene, then you will start with the terminal. I'm not saying start the numbering with the terminal. Please listen very carefully. You will, when you are choosing the chain, then you will be starting from that terminal which is farthest from the junction, That means you have to also look at junctions. Where are the junctions? This is a junction. This is a junction, right? There are two junctions, yes or no?
Yes.
Tell me.
Yes, sir.
Okay. So now you are going to start numbering. You are going to start numbering from A, because this terminal is the farthest from junction. Yes or no?
Yes, sir.
And now this is going to just help you in identifying, and it is going to save your time. So you'll start from here, CH3, CH2. Now you came to a junction. Now you have three choices: towards B, towards E, or towards C or D. Which side should I go? B, C, D, E. किधर जाएं हम? यहाँ से towards D. Now I have again got a junction. Now whether I go to D or E, it is the same thing. So I will go here. All of you, any problem?
No, sir.
This is very important. Only not numbering. Numbering में please इसको mix मत कीजिएगा. While choosing chain, start from terminal. That terminal which is farthest from junction. Okay, which is farthest from junction. So how many carbons do we have? 1, 2, 3, 4, 5, 6 carbon atoms. So we have things such as functional group, then we have unsaturation, and then we have the parent. So functional group is E, unsaturation is A, and due to alkene, the parent is going to be hex. Now let us look at the substituent. Yeah, substituent. Now we have substituent. So what are the substituents? We have this substituent.
So
we have how many?
trimethyl.
Okay, trimethyl. This is a substituent. Trimethyl.
Is it methyl, right?
Methyl. Correct.
Okay.
Trimethyl. So how many substituents do you have? You have 3 substituents. You should be having 3 numbers. You should be having 3 numbers. So while numbering, you have to start with the terminal that is nearest to the junction.
3
नहीं 1 से start होगा ना, ये 1 2 होगा, 3 4 4 4 4 ना.
2 4 4 trimethyl.
यहाँ पे आपको दिक्कत है, यहाँ पे आपको दिक्कत है ना मोहम्मद?
Yes, sir.
ओके फाइन. टर्मिनल्स का काम हो गया, तो इनको हम हटा देते हैं. So whenever you are numbering, there are only 2 ways to number. Either you can number like this, or you can number like this. Correct? Yes or no?
Yes, sir.
Okay. Then there is a rule of lowest locant according to Iupac nomenclature. Lowest locant. Why do we number something? We number the alkyl chain because we want to tell these substituents, or if you have unsaturation or the functional group, where are they present, and that is why we number it. So we have trimethyl. That means we have 3 substituents. Those are methyl, and we have to number it. We have to number, and we have to tell where are their positions. So I can also use this numbering. Wait a second. Actually, my flux is on, so I can't see what color am I using. I've used blue and red. Okay, fine. So either the blue one or the red one. Red one. So lowest locant says that whatever numbers you are using, it should be, the sum should be smallest sum. The sum of numbers used for location should be smallest. So now you have choice between the blue and the red. So if I talk about the blue, so I will be using 3 2 times, yes or no? Because how will I write? if I am writing with the blue one, then I will be writing 3, 3,
5.
5 trimethyl, right? And if I'm writing with the red one, then I will be writing 2, 4, 4 trimethyl, right?
Yes, sir.
Trimethyl. Now, if I add them, what is going to happen? Which is larger?
3, 3, 5 will be larger.
है ना? So for the blue one, we'll be having 3 plus 3 plus 5, which will be equal to how much? 11.
11.
If I use the red one, then it will be 2 plus 4 plus
10.
4, that is equal to 10. So which is low? 10 or 11?
10. Red.
10. है ना? 10 is less. That is why we'll be using 10. लेकिन ऐसे आपको नहीं करना पड़ेगा हमेशा, है ना? So see, this is the rule, but you have science, yes or no? So tell me, you have science and you have computer science also, correct, Mohammed Umar?
Yes, sir.
Now think in terms of computation and algorithm. So if you are a computer and if you want to write a program that is going to give you an Iupac nomenclature, what will you do? You will not count, है ना? So this is going to take a lot of time computationally, that if you are going to count each of the like what I can say, count, I mean do all the numberings. This is one possibility, this is another possibility, that is another possibility. Then you add all the numbers and do all of those things. That is going to take a lot of time. So one thing you can do is, you can see, you can start with that carbon atom that is nearest to the substituent. Yes or no?
Yes, sir.
So if I start from here, obviously I'm going to get 1, 2, 3, 4, 5, and 6. And if you have a class, something like this, let us say you have one methyl group here also. You have one methyl group here also. Then what is going to happen? Now I can start from here also and here also, because both. Then you will look next. Now here I will see that this is my carbon atom, which is going to break the tie. Because the third carbon atom, if I start from here, it has a substituent and it should be mentioned in the number, but the third carbon, it is not having anything. So basically the idea is to start from that carbon atom which is nearest. Now you tell me which is nearest to the substituent, A or B?
B.
B. Both are same na abhi to. But tell me, how will you choose here? A or B?
So A is closer to the substituent one.
A na? A will be the choice, because the third carbon atom, because we can't decide with 2. So I am removing 2. Use to kuch hona hi nahi, because 2 is same. What is different? Then I will look now which is nearest to the junction, which is nearest to the substituent. Then this A is nearest to the substituent.
Okay, sir. Okay.
Got it?
Yes, sir.
Okay,
got it.
fine. So you have to name a compound that is tetra tert butyl methane. This may look like an Iupac nomenclature, but it is not an Iupac nomenclature. It is rather a common name. Okay. So you are using tetra tert butyl methane. You can write it once again. Okay. So methane means what? CH4? No. Methane means CH4 nahi hota hai Iupac nomenclature mein. Methane means only one carbon atom, because methane is nothing. Methane is like we have to see meth. AN means something else, E means something else. All of you know this, right? So methane aisa nahi CH4 bana diya. No. You will write only one carbon atom. That is my parent chain here according to this name. Then there is tetra. Tetra means there are 4 groups attached to it. Okay, there are 4 groups attached to it. Tert butyl. What is the tert butyl group? If you remember slightly from the organic chemistry part, what is tert butyl? This group.
Sir, it is yes.
This group is the tert butyl group. Okay, that means the carbon atom which is attached to main chain, the carbon atom that is attached to main chain, it is attached to further 3 methyl groups. Okay, so now you have to name this. Iupac nomenclature. Now you can see that obviously, like meth is not the longest chain. No? So the one that they have given, tetra-tert-butyl, it is a common name and it is not a Iupac. So try this. I'm giving you 2 minutes. Just find out the parent chain, nothing else. Find out the parent chain.
So tert means is it's attached to 3 other carbons, right?
Tert means, yeah, tertiary, 3 degree.
Okay, sir.
So if it was ethane, then the carbon would have been attached to 3 other ethane, right?
What do you mean? Where was ethane?
If it was ethane,
Rather than methane?
yes, instead of methane, yeah.
Instead of methane, everything else would be same?
Would it be different?
Yes, no, because if you're talking about ethane and you're telling carbon and carbon, okay. Now this carbon can only have 3 other groups. This carbon can only have 3 other groups. So obviously tetra cannot be there. Yes or no? Tertiary butyl, a group can be there. This is a group. I know. But if I want to, this is the structure that you're telling. No? This is the ethane. And I only have 3 more groups. No? So
Yes, sir.
tetra won't be there. There will be something else. Tetra won't be there. But in common name, that is not how we name things. Common names, that is not how we name things. Okay. You can't have a generalized, you can have a generalized use case, but you have to talk about like correct questions, like the name that you suggested now, tetra-tert-butyl ethane, that is not going to be correct, है ना? तो आपको जब भी Iupac nomenclature में कोई सवाल मिले, so never start thinking कि और क्या सवाल हो सकता है इस तरह का. You just do many questions, because when you start making questions in Iupac nomenclature, there is a large possibility that you are going to mess it up. And most importantly, if you are going from name to structure, क्योंकि name ऐसे दिमाग में लाना, it's tough. You can draw any structure and start naming it. That is fine. That's perfectly fine. But you can't just imagine or name a structure, the Iupac name, and it will be correct. In the most of the cases, it won't be correct. So tell me about this. Did you get the parent? Yes or no? Parent मिला किसी को? Parent के लिए
I
तो
think it's pentane.
Correct, pentane. So see, all of these CH3, they are same. Yes or no? The terminal CH3s. If I say this A, B, C, D, E, F, G, H, I, J, K, L, all of these are what? Same? Yes or no? Can you see that?
Yes,
Or
sir.
are they different for you? They are same. Okay. That means I can start with any carbon. So I'm starting from this carbon atom. So when they are same, it means that I can start with any carbon. So I'm starting from this carbon atom, that is CH3. Then I will move. Then I have got a junction. Now, what I have to do, I will move forward, because there is only one carbon atom. This side I can see more carbon atoms. Now, when I am at this carbon atom, I can see here also I have C, here also I have C, here also I have C. Then after that we have CH3, here also CH3, here also CH3. So I will just keep move forward, because all of the groups are C. I can move anywhere, but it's better to move in a straight line. It is going to make things easy for me. make things easy for me, but I'm not doing anything wrong to make things easy for me. Okay, ऐसा नहीं कि हमेशा straight chain ले लीजिएगा, but in this case I can take straight chain. Now I just need to identify the substituents. So I have got few substituents like this. This is a substituent, the substituent methyl, this is a methyl, this is a methyl. Then I have these two substituents which are tertiary butyl. Okay, so I have these substituents are same. We have 4 methyl groups, and then we have a tertiary butyl group, and here also a tertiary butyl group. Now with the numbering also you can see it is it doesn't make any difference. You can start numbering from anywhere. Both of the cases the lowest locant will be same only. 1, 2, 3, 4, 5. Now we have got pentane, and we are looking for the substituents. So for substituents we have second carbon 2, 2, 4, 4, tetramethyl. This is one group of the substituent, and then we have 3, 3, third butyl. When you are naming it, please see if you have anything that is resembling numbers, and as secondary 2 degree, primary 1 degree, and tertiary that means 3 degree. So whenever you are representing any number, that means you are not going to take it as names. Okay, you are not going to take this as the name. What is the name of the substituents? The name of the substituents are methyl and butyl. Methyl and butyl. Now in this case you can see which is alphabetically ahead. Butyl is ahead. So first of all we'll write 3, 3, third butyl. Then we have 2, 2, 4, 4, 4 tetra methyl methyl pentane. Okay, so this is it about all the structures, and then we have also done some nomenclature. So tomorrow we will be studying about the preparation of preparation. Okay,
So what about the
and
notes?
notes हम दे रहे हैं ना आपको.
Say the same or the one note?
हाँ, the one note.
Okay.
Okay.
I mean, I actually already have your one note with me.
Yeah. I know that. Okay, so you have the view access, no?
Yes, sir.
हाँ, तो ये भी हो सकता है. So but just wait for a second, है ना? I'm just giving you some questions. You know, all of you, right? 1 degree, 2 degree, and 3 degree. How to look for 1 degree, 2 degree, 3 degree? Yes or no? 1 degree carbon, 2 degree carbon, 3 degree carbon.
So I don't know.